Ladies and gentlemen, a warm welcome to our today's webinar. This webinar is all about UltraMap 5.0. We are doing a deep dive into the features of this new software release, and then we'll give you some best practice examples. Today's speakers are Bernhard Schachinger, who is our application team specialist. Well, and I'm also talking for a few minutes, giving a kind of an introduction before I hand over to Bernhard as the specialist. What we have prepared for today is we'll give you an overview about the development path of UltraMap. Then we talk about the latest UltraMap 5.0 features. We give you some demonstration and best practice examples. And then last but not least, we have our question and answer session, which always comes at the end of the webinar, where we are looking forward to talk to you and answer all the questions you might have. If you have questions during the webinar, please type them in the Q&A pane of the software system. You find it on the software, and we'll collect all the questions and answer them at the end of the webinar in the Q&A session. Please note that this webinar will be recorded, and we will send you a link of the recording after the webinar. UltraMap 5.0 is a breathtaking new release. Many very interesting and special features went into that release. Before Bernhard does the deep dive into all these details, I want to spend some minute and give you kind of a recap on how the software developed, what the philosophy was behind, how UltraMap developed over all these many years. And also I want to talk a little bit about the associated hardware, the Ultracam. Over the years, UltraMap had a very rich history of innovative features. The software was always an integrated and important part of the overall Ultracam solution. It all started with the UCD in the year 2003, where the processing software was called OPC, Office Processing Center, and that was literally the software which was needed to process the raw imagery into level 2 and level 3 images. The history of UltraMap started in the year 2009 with its first version. It literally covered the first step of the processing chain, the UltraMap Essentials, and at that time we introduced distributed processing with automated load balancing into the processing software, which was already a very important step forward in using this existing IT system as efficient as possible. In addition, we also introduced an aerotriangulation module, so first in time UltraMap, or the Ultracam processing system, was capable of not doing only the essential steps, but we had already an extension of the workflow to the AT module. In 2010, the next version of UltraMap was launched, version 2, where we added a monolithic core. The so-called monolithic core improved the stitching of the sub-images in very homogeneous terrain. We also added very rich new radiometric features, absolutely breathtaking at that time, and we also worked on the AT solution of UltraMap. 2 years later, 2012, we introduced UltraMap version 3, and that UltraMap version was all under the theme of 3D. So we added the dense matching module and the ortho pipeline, which allowed in a seamless workflow to generate point clouds from the imagery and then derive surface model and terrain model from that point cloud, and then later use it in the ortho pipeline to generate automatically a DSM ortho and a DTM ortho. Then we had about 4 years of development time, and in 2016 we launched UltraMap version 4. That was a long period, but a lot happened in the background and the basic foundation of the software system. UltraMap with the version 4 is now able to deal with really large projects. Not only 10 or 20 images, we are talking about 50,000 images, 60,000 images, and much more in one project. That was necessary, as we have seen from our Ultracam customer base that the projects are getting bigger and bigger, and it makes sense to process everything in one project, no need to split it. And so we worked a lot to change the whole internal structure and architecture of the software so that the software is available to deal with, at the end, a kind of an unlimited amount of project size or image amount. Besides that, we had an initiative called Geometry, where we added features which improved the geometric accuracy of the Ultracam in various flight conditions and temperature changes, altitude changes. Although with the version 4, we introduced a new color balancing. Color balancing was always a key feature of UltraMap and continues to be, as this saves a ton of manual work. And with the version 4, we also introduced a new approach to the color balancing with improved algorithms. Another big feature, saving a ton of manual work for our customer base too, is that we had, as always, we had our nadir area triangulation, but we added a seamless oblique triangulation for our oblique cameras, and that is now integrated in one consistent workflow, so that nadir and oblique AT support each other and lead to an overall improved result. And as always, with the philosophy of UltraMap, that was done in an automated way to achieve the utmost quality with the shortest possible or shortest necessary manual interaction. And last but not least, we also worked on 3D, so we introduced a module called 3D Tin, which enabled to generate a 3D tin out of the point cloud, the DSM and the DTMs, which have been generated before. Well, and as of now, we are launching UltraMap version 5, the latest version of the software, which is now in its final release. We had a kind of a release candidate in August, which we were promoting and we were already talking about it. But now, as of today, Bernhard will later introduce you the final release of UltraMap version 5.0. We are absolutely proud about this release. What we added is a new workflow for DSM and DTM generation with new algorithms and a new way to deal with it. We introduced machine learning to generate a better DTM. We now integrated in the software a seamless DSM and DTM editing by using the same set of tools so that the graphical interface and the usability is absolutely easy and very efficient. A feature where we have been asked for since quite a while is terrain model export. So thanks to the improved quality of the terrain model, we are now exporting it as a data set. And we improved the vector data handling. So UltraMap 5.0 contains a rich set of features. What comes next? So, well, we have a ton of ideas. We are getting great feedback from our customer base, so we'll for sure not stop innovating on UltraMap. We are currently working on improving water flattening, for example, and we are also working on improving water texturing. So these will be features which you will see in the upcoming releases of UltraMap. Well, software is nothing without the hardware and vice versa. So I want to spend a minute or two in talking about the Ultracams. Before we launched the Osprey 4.1, we had 3 camera generations, the UCD, the UCX series. Then we came up with these birds of prey names. In 2011, we launched the Eagle, and then subsequently we had the Condor and the Ospreys. And now we are moving with this camera family into the 4th camera generation. And if we recap what happened over these years, I would say this is really an impressive journey over the last 17 years. When we look on the footprint size of the UCD, it feels like a postcard compared to the footprint size of an Eagle you have nowadays, which more feels like a poster if you compare it to what we have had 17 years ago. The UCD had 11,000 pixels across the flight strip. The Eagle has 26,000 pixels across the flight strip. So that more than doubled. It's a factor of 2.3 just in one dimension of the image size. A huge impact on the flying efficiency. The frame rate changed, okay, from 1 second it went a bit slower. With the current Eagle you can do 1.5 second. Will again be faster with the Eagle 4.1, but that's down the road. So that feels a bit like a disadvantage, but it's totally the opposite is true, because in the same time the pixel count, the amount of pixels collected by one image increased by a factor of more than 5. So we had literally almost no impact on the frame rate, but the image grew pixel-wise by a factor of 5. And that means that the storage system, the internal camera technology, the internal camera electronic now needs to deal with 5 times more data in almost the same time. Also, when we look on the pixels on the sensor, they went down from 9 micrometer to 4 micrometer, so was reduced by more than half. But the image content, the image quality improved. So the noise level went down thanks to newer electronic and better CCDs. So with the shrinking pixels, we even improved the image quality coming from the D to the Eagle. With all this increasing capability of the camera systems, nevertheless, they shrinked in size by half. They shrinked in weight, so they got lighter by half. And also the power consumption is now about 50% on what a UCD in the former days consumed. We are now entering into the camera generation number 4. The Osprey as the first sensor on this was introduced just a few months ago. So the Osprey 4.1 is now available and is already flying for the Vexcel data program, and in the very near future also on the commercial market. And what we see from this sensor is just breathtaking. The image quality is just fantastic, the radiometry is great, and the flying efficiency is just crazy compared to the former oblique camera. And also when you compare it to competing sensors, it's just amazing what this camera can do thanks to the width of the flight strip, but also thanks to a frame rate of a second or less. So we can fly this camera incredibly fast, and we are almost doubling the flying efficiency in our own projects. And also our customer base will very shortly and very soon enjoy these benefits for their own flying. With the Osprey 4.1, we did the introduction of CMOS technology into our camera base, and all the other cameras will follow subsequently in the next years. Next in line will be the Condor, which we are flying for the VD Vexcel data program, and then again next in line after the Condor there will be coming an Eagle 4.1, also fully CMOS based. And from the studies, from the research we are currently doing, although all these cameras will be outperforming sensors who are again setting a new standard in the industry. Well, that brings me to the end of my introductory part. I am now happy to hand over to Bernhard Schachinger, who will jump into the topic of this webinar and talk about the final release of UltraMap 5.0. I really do hope you enjoy it, and Bernhard, the floor is yours now.
Hello everyone, and welcome to the live demo part of this webinar. My name is Bernhard Schachinger. I work as application specialist at Vexcel here in Graz, Austria, and I'm happy to show you some of the exciting features of UltraMap. So first of all, let's start with a general overview of UltraMap, and then we will go more into the details of the new features. UltraMap covers the full photogrammetric workflow for Ultracam cameras, ranging from post-processing the raw imagery to area triangulation to radiometric adjustment, including an automated color balancing, then creating the DSM and DTM, ortho mosaiking, and finally 3D mesh creation. Let's have a quick look at these workflow steps with the example of this dataset from Graz, Austria. This imagery was captured with the new UCO 4.1 oblique camera at a ground sampling distance of 5 cm and at an overlap of 80% in flight direction and 60% sidewards. First, the post-processed images are ingested into the software, and the important project information like camera parameters are set up automatically based on the camera calibration data. The workflow area here on the left lists all the actions that you do throughout the workflow. The window on the right shows the data. In the next steps, the image block was prepared and post-processed GPS-INS data was imported. Then the automated extraction of type points was done. The measurement of type points is done fully automatically in all viewing directions, so in both nadir and oblique images if available. Ground control points can be imported and measured, and then all data is combined in the bundle adjustment to get accurate capture positions and angles of rotations. The results of the bundle adjustment can be visualized in 3D, are summarized in a report, or can be exported to various file formats. Next in the workflow is the module for radiometric image adjustment. From the bundle adjustment result, the automated color balancing is started. This compensates differences in the visual appearance of the flight lines and viewing directions due to atmospheric conditions or changes in date and time of the image acquisition. The result of the color balancing is shown on a low-resolution ortho mosaic so that the successful compensation can be verified on the preview of the final product. Radiometric fine-tuning can be done on this low-resolution ortho, and the effects are automatically applied to the single images in the background. At this point, the single images can be exported to TIFF or JPEG, or the user can proceed in the UltraMap workflow with Ortho Production. This is new with UltraMap version 5, that the Ortho module is no standalone software anymore, but is fully integrated into UltraMap Studio. The low-resolution ortho serves as a base layer to select regions of interest for processing to full resolution. First, the DSM is generated with dense image matching. With integrated land cover classification, ground and non-ground objects are automatically identified for filtering the DSM to the DTM. Then in the next step, ortho mosaics are created. Images projected onto the DSM result in the true ortho and do not show any building lane. So all objects are projected straight down. In contrast to that, the traditional approach with the ortho on the DTM shows the side of the buildings, well visible here at the example of this tall building. The last step in the workflow is the processing of the 3D mesh. This is again a fully automated process started from the base layer. And here we see all the tiles that have already been generated for the 3D result. For the 3D reconstruction, all available image types are used, so in case of this dataset, all nadir and oblique images are used for the geometry reconstruction and the texturing. Fine details on the roofs and facades are well reconstructed so that the 3D model is of very high quality, like here the main cathedral in Graz. For a closer look at the ortho workflow, I switch to another dataset. This is a sample from our data program, Köln and Bonn in Germany, captured with the Ultracam Condor at 60 cm resolution in the panchromatic channel and 20 cm in RGB. First, the base layer was processed to allow an overview of the project area with very fast processing time. Then the tiles for the region of interest can be selected for processing. For easier selection of complex AOIs, there is now a new feature available. In the management of polygons, you can easily create a new layer, draw a polygon, and then select all the tiles that intersect with this polygon. You could do the same also with imported polygons. Based on this tile selection, you can start the processing of data. This does not only work for starting to process, but also helps to select map sheets for exporting. With the same tool, you can also define restricted areas so that the content within the polygon is excluded from exporting. Just change the usage type of the layer. The new handling of polygons now supports GeoJSON in addition to the shapefile for import and export. So after the selection of tiles, processing can be started. In the dialog window, the required output products can be selected. If processing the DTM, then this option here, the Preserve Bridges in DTM, is quite important to consider. UltraMap tries to automatically detect bridges in the data, and when the checkbox is activated, then these bridges are represented in the DTM by the same height values as in the DSM. If that is deactivated, then the bridges are eliminated from the DTM. Keeping the bridges makes sense when the DTM is used to create a DTM-based orthomosaic, because then bridges are best possible shown in the ortho. If the DTM should be used for some kind of analysis or simulation, such as hydrological modeling, then bridges should not be included as they influence the result. Let's have a look at an example where the DTM was processed, including the bridges for the DTM ortho. The bridge looks very nice in the DTM ortho, and here we see the scene in the DTM with the bridge being included. The same scene was processed to exclude the bridge. And the difference is clearly visible in the orthomosaic on this bridge, where the height does not match the image content, and thus there is this displacement of the road. So here the bridge is not included in the DTM. The DTM is generated with the following automated approach. First, there is semantic segmentation of the imagery based on RGB and near-infrared, and then this segmentation is combined with the heights from the DSM to detect ground and non-ground objects. The non-ground objects are removed from the DSM and the holes filled with interpolated height values. As no automated workflow can provide results which are 100% perfect, there are tools to inspect the data and do modifications where needed. This layer, the non-ground objects, shows with blue color the difference from the DSM and the DTM. Dark blue means that objects are eliminated from the DSM and the DTM is therefore lower. Light blue means that the DTM is higher than the DSM. Typically, buildings and high vegetation such as trees are removed from DSM and therefore dark blue. And this layer here shows in yellow the automatically detected bridges which were discussed before. Using these layers, the user can check which parts were filtered. If any untypical filtering is found, then the data can be loaded into the height field editor for manual modification. Here, a building was not fully detected and part of it remained in the DTM and should be removed. So let's load these tiles into the editor, remove the spike and then update the DTM. So using the smoothing tool, we can get rid of this artifact and then we save and close the editor and the new data is applied to the DTM. Up there in the north, there is a bridge which was not fully detected by the software, so it is incomplete in the DTM. So let's select these tiles and load the data in the editor. The bridge is fine in the DSM, but it has missing parts in the DTM. Therefore, the easiest way to fix it is to use this ground tool, to select the region of the bridge in the DSM to be used in the DTM. So drawing a polygon, we tell the software to use exactly these height values of the DSM in the DTM. So switching off the edits and then using that preview button, we see the DTM before the edit and now after the edit. In this way, any features from the DSM could be easily transferred to the DTM, like any buildings, dams, or even trees. The photogrammetric approach works usually well as long as some pixels on the ground are visible. The approach is limited in dense forested areas, where the photos just show the tree canopy but not the ground underneath. If your project requires a detailed DTM in the forest areas, then you can import the DTM from an external source and combine it with the internal DTM. This polygon describes the area in the forest for which a detailed DTM is required. The usage of this polygon is set to DTM import region, so that the software knows to import the data exactly for this extent. The internal DTM looks like that, so the ground in the forest is rather flat. So let's select the directory with the external DTM and start the import. The import is finished and both DTMs are merged. The transition between the DTMs can be modified with the editor as needed. So we will apply some smoothing here at the edges where needed. So here we see the transition from the imported DTM with the details to the internal DTM, which is rather smooth in this forest area. So I apply some smoothing here to get rid of this edge. Now we saved and closed the editor, and the modified tiles are now ready for reprocessing the DTM-based orthophoto in this region. So for the reprocessing, we can close the polygon management and switch to the DTM Ortho tab, where the edited tiles are already highlighted. In the navigation area, we select now Submit Ortho, and in this dialog window that will appear, we have the option to reprocess the orthophoto. So we can submit now this job, and the DTM-based orthophoto is being reprocessed for these tiles where we have modified the DTM. So finally, after reprocessing, the orthophoto is then ready for exporting to be used in any other software. So that's it for my part of the live demonstration in this webinar. Thank you, and I'm handing back over to Alexander.
Thank you very much, Bernhard. That was great. And I'm now happy to open up the Q&A session. So if you not already have done, please be so kind and type your questions into the Q&A pane of the software system. And we are looking forward to receive your comments and questions, and we are looking forward to answer them. Thank you very much.
I'll start with the first question. To take advantage of the new features in version 5, do we need to process the block again from scratch in version 5, or can we use an existing UltraMap version 4 project?
This is a very good question, very important. As there are a number of changes in version 5 compared to version 4. So, of course, it will always be beneficial to process the full data set, but in this case, on this jump of versions, taking the level 2 images, so the post-processed images from version 4, that should be fine. Also taking the error triangulation result. But from there, from the error triangulation result, I would recommend to start with a reprocessing of the color balancing, and from there reprocessing the DSM, DTM, and orthos. As in that case, you will take advantage of all the changes which have an effect on the overall results and which bring the most benefits.
Thanks, Bernhard. Next question is, taking into account the capabilities integrated in the new UltraMap, do you think that it is possible to obtain a DTM for large territories with a complex relief only from images, or these must be combined with LIDAR data?
So this depends very much on the project needs and also on the terrain that you need to cover with the data. So as discussed earlier, with the photogrammetric approach, the DTM production works well as long as there are here and there a few pixels which can see to the ground. So if you have very large forested areas with very dense forest, then the photogrammetric approach has some limits, and therefore UltraMap offers the tool to import the DTM from an external source, so from a LIDAR, a data acquisition, or anything else. In terrain where there are a lot of buildings, urban terrain, rural land with grass and fields, all that is very well handled, and the DTM will be fine. Also with some smaller forest areas, but as mentioned before, large forest areas, these are the areas where the approach is limited.
Great. How deals UltraMap with DSM generation from images acquired in very different radiometric conditions? What about the mosaiking process in this situation?
Yeah, so the dance matching for the DSM, this is using the images of the panchromatic channel at full resolution before any changes to the radiometry have been applied or before any color balancing is done. So this is the raw image data with the full 16-bit, so the best possible image source that is available for the dance matching. If the images are acquired under different radiometric conditions, then as long as there are features which can be identified in all these images, then the reconstruction works well. However, if you have images taken under summer conditions, other images taken under winter conditions with snow cover, then there is obviously a challenge to properly match all the pixels. But as long as it's not dramatic changes, this is fine to have a time difference of not only a few days, but also weeks or months. And what about the mosaiking process in this situation? Well, for the auto mosaic, the color balancing is very important. So the automated color balancing tries to reduce these differences as good as possible. So differences because of atmosphere or light, or differences because also of the camera settings, so exposure time, for example, these can be compensated well. However, the software cannot compensate differences based on the season of the year. So there are some limits, of course. We cannot artificially generate it leaf off or leaf on conditions, but otherwise the mosaiking tries to balance that well.
Good. For obtaining a good DSM, it is recommended to have an 80-60 overlap in urban areas. What are the recommended values for large areas that combine urban, forestry, mountainous, flat areas?
Yeah. For urban areas, it is highly recommended to fly with 80% forward overlap and 60% sideward to minimize the occlusions next to buildings. For areas where there is a combination of urban, forest, mountains, and so on, I would say that depends on your project. So if this is a large project area where you have this mix of land cover, it might make sense to adapt the flight plan according to these regions, but difficult to give a general answer there. This needs to be discussed depending on your project.
All right. Next one is smaller pixels normally worsen the signal to noise ratio. What is the nominal signal to noise ratio for the Eagle M3? And have you noticed a quantifiable decrease of the signal noise ratio along with the ever smaller pixel size? Bernhard, do you know the signal to noise ratio out of your memory from the Eagle, for the Eagle?
I don't have this number ready right now.
Yeah. So I can give a more generic answer on this. Generally speaking, yes, that is correct. Smaller pixels worsen the signal to noise ratio. However, over all the years coming from the D to the UC Eagle, the construction, the layout, the design of the CCD changed. So there were significant improvements in the CCD design by itself. And so even with the pixels getting smaller, the signal to noise ratio was constantly improved and maintained at a high level. So we have not seen an impact in the image quality, and this is a combination of improvements in the CCD design over the years, and also over the years we improved our camera internal electronic, and all that resulted in a better image quality in spite of smaller pixels. So signal to noise ratio is not everything. It is also the electronic, which is working together with the CCD, and this is all custom designed by Vexcel. So we have a lot of control and could design our own improvements for the electronic. Does DSM DTM module support GPU processing? What is recommended for large areas to process with CPU or to use GPUs?
Yeah, so these modules support processing on the GPU. So the standard mode is processing on the CPU, but adding optionally GPUs that speeds up the process. So adding GPUs that is gain in processing performance. So for large areas, it is definitely beneficial to add GPUs, as that speeds up the processing.
Are all orthos created considered true orthos?
Well, as shown in the demo, the ortho, which is generated based on the DSM, we call that the DSM ortho. That is the true orthophoto, so no building lean, no facades. And the orthophoto, which is generated based on the DTM, that includes building lean. So that is not considered a true ortho. That is like what was known as the orthophoto for many, many years in the industry. So that is like the traditional orthophoto.
How are Earth's curvature and atmospheric refraction corrections handled for oblique images in UltraMap?
Yeah, this is a very important component of the workflow. So for the oblique images, there is the same challenge as for the nadir images to somehow model the Earth curvature and the atmosphere and the refraction effect, and to get rid of that. For the oblique images, this is a little bit more complex than for the nadirs due to the viewing direction. So we have adapted the formulas to take care of this viewing direction, to take into account the extent of the images, so the footprint on the ground, to have all these corrections very well adapted to all regions within the oblique image. So this is a fully consistent correction, let's say, for all pixels within the images, both for nadir and oblique.
If the user selects a subset of obliques, 10% for TPC, for AT purposes and efficiency, will this impact the CB quality?
Yeah, so this relates to a very specific setting for the type point collection. So that is TPC. And will this impact the CB, so the color balancing quality? Short answer is no. This will not have an impact on the color balancing quality. So this subset of obliques, or the parameter to select a subset of the obliques for the type point collection, or to select all of the obliques for the type point collection, this has rather an effect on the processing performance, most of all. And it has some effect also on the quality of the orientation of the oblique images. So at the cost of higher processing time, if using all of the obliques, there is the benefit of a little increased quality of the obliques in air triangulation. However, this is in a magnitude that will not have an effect on the color balancing, as the color balancing is processed. Not processed on the full resolution, as you can see from the preview ortho, which is available after the color balancing processing has finished. However, of course, the color balancing results, after all the optimization is done, these are applied, of course, to the full resolution images.
Why is the gradient tool only available in block radiometry?
Yeah, this tool was invented to handle some tilts in the brightness of a block, so of the full image block which is being processed, and then the color balancing result is shown on the preview ortho. That could have a tendency to one of the corners, maybe depending on the image content, to get brighter or darker, or because some clouds had an effect in some region, and therefore this gradient tool was developed, and therefore it makes sense to use that in the block radiometry part of the software. So that is the reason, that is the background for that. So a little bit more information. So we are aware of some limitations of this tool. So thanks to the feedback to a lot of our customers, there will be some improvements or some, let's say, additional features coming with some of the next versions.
Great. What is the difference in processing times between true ortho and regular? A percentage number is fine. A percentage number is fine. So
the ortho processing itself is very comparable, but before processing the ortho mosaic, there is the DSM processing, and then from the DSM, the DTM is derived. So that in total, that gives then the processing. So considering that, the true ortho, so the DSM-based orthophoto, is available within a shorter time frame, as it just requires the DSM to be processed. The DTM-based orthophoto requires, in addition, the DTM to be processed. Therefore, this adds to the total number.
Great. Have Vexcel bench tested different GPUs for throughput?
Some GPUs have been tested. However, we cannot test the full range of GPUs which are available on the market. Therefore, we cannot give a result for all of these, but some of these GPUs are in use within the development system and also within our production system. So we have some experience with various GPUs.
Okay, so hey, thank you very much for all these questions. Okay, another one is coming. What are the current available formats for the 3D mesh exports?
So the 3D mesh can be exported right now as OBJ, OSGB, and LOD3 export.
So the first question is, I would like to know the maximum images in a single AT block for Osprey 4.1, 7.5 centimeter ground sample distance, 80-60 overlap. And aligned to that, can the AT results be exported to the info platform? Bernhard, that's a question for you. Please be so kind and have a look on it.
Yeah, hello. So the maximum number of images, this is a very good question. There is not a hard number that is coded into the software, and this number of images per block cannot be exceeded. So the maximum number of images depends on a few parameters. Not only the flight parameters, also configuration of flight lines and so on. So in that case, so if that is the question with the background of a very large project, I suggest that you let us know details about this project, and then we can give you some feedback on that, since there is not an easy and general answer to this question. This also depends on the processing hardware that is available. So we need to take that into account, since the type point extraction needs some hardware resources on the backend, on the processing servers, and the bundle adjustment also needs various hardware resources. So we should discuss that all in detail if you have information about the project and can provide that. And for the other part of this question, AT results to be exported to info platform. Yes, so we provide some ways to export the data from our AT module. It depends on the type of information that you want to transfer between UltraMap and other software, for how to best do that. And also for this question, please let us know details about your project and the request, and then we can recommend the best approach.
Bernhard, coming back to the number of images, but we are talking about 10,000 of images. So is this something you can indicate? So it's not in the thousands of images; it's more in the several 10,000s. Yes,
absolutely right. So we are talking about somewhere in the range of 25,000 images. And in case of the Osprey, this does not include nadir and oblique images, but this relates to capture events.
Mm-hmm. Mm-hmm. Yeah. So that means the actual image count is 5 times higher.
Yeah.
Yeah. Okay. Thank you. Next question is, I would like to know about the calibration, field pattern, and bore side calculations in Ultracam software. Bernhard, can you state something here?
Yeah, so for doing the field calibrations, we provide a document with a guideline for how to do the flight planning and how to do the distribution of the type points. So this can be provided upon request, and this gives all the information for how to prepare the flight and then what kind of data to send to us for doing the field calibration procedure. And regarding bore side calculations in Ultracam software, so the AT module, the bundle adjustment, does always estimate the bore side angles and apply them, of course, to the solution. So bore side angles can be read directly from the error triangulation report.
Thanks, Bernhard. Next one is, I would like to know what data format can we export 3D mesh to be used in other CAD and GIS software?
So for the mesh, we provide the export in the formats OBJ, OSGB, and LOD3 export.
Great, thanks. Next one, how can seam lines of the ortho mosaic be checked and edited?
Yes, so this is a part that we did not show in the live demo, but still it is a very important component in our software. We have an overlay for the ortho mosaic, both for the DSM ortho and the DTM ortho, where we can visualize all the single images that contribute to the ortho mosaic. And this can be modified. So the operator can click directly in an image and modify the border to the neighboring image, and then reprocess the orthophoto so that the data set is consistent. This is similar, or let's say the very same approach for the DSM ortho and the DTM ortho. And then after doing this check in UltraMap and editing in UltraMap, then of course the scene lens can also be exported.
Great. Nice presentation. Do you have any recommendation for a 3D viewer for viewing, inspecting of the 3D mesh from UltraMap outside of the Studio module?
Yeah, so since we provide the export to standard file formats, almost any viewer can interact with the data. So I would say the recommended viewer depends mostly on the application you are looking for. If it is just for visualization of the data, or if you are looking for combination of the 3D mesh with other data, or using the 3D mesh for some kind of analysis, line of sight, or simulations, or so on. So depending on the use case, we could recommend a viewer that would definitely help you.
What is the building lean percentage in the generated DSM?
Yeah, the DSM, all the surface is projected straight down, so it's a 2.5D data set. Therefore, there should not be any building lean, and no facades, no sides of buildings should be visible in the DSM. In data sets with very low overlap, there might still be some limitations to that due to some occlusions, but with typical flight plans for urban mapping, the building lane does not exist, and buildings are projected straight down.
Are you likely to include 3D mesh export as cesium 3D tiles and I3S in the future?
Yes, absolutely. So these two file formats, they are on our list for additional formats to add to the product.
Fantastic. What is the overall DTM accuracy produced from a 20 centimeter GSD and 80-60 overlap flight plan with a condor for a complex relief, flat hills, mountains?
Yeah, good question. So the DTM accuracy, it does not only depend on the relief, so flat hills, mountains, but it also very strongly depends on the land cover. So if that is an urban area, rural land, forest, and because this decides how well we can reconstruct the terrain from with photogrammetric approach, and where and how much of interpolation is needed. So since this depends on various parameters, there's not a general easy answer to that. It's rather depending on the project area. However, with the approach that we follow, we try to filter the DSM to ground and non-ground areas. And in all these regions where we identified the DSM to be ground, the DSM and the DTM are identical. So if this portion of the data is large, then the DTM has the same accuracy as the DSM.
All right. In what file format is enabled to export DSM and DTM from UltraMap?
So these data sets can now be exported as GeoTIFF tiles or TIFF plus world file. And the DSM is also supported now to be exported as a point cloud LAS. This point cloud can be colorized, so the RGB values are attached to the single points. Also, near infrared is available to be included for the point cloud.
Great. So next one is, have you any predicted timescale for rollout the version upgrade which will incorporate water flattening and water texturing?
Oh, sorry, I was muted. So there is not yet a release date for this version, but implementation is ongoing for this. So this will be one of the next releases scheduled for 2020. Sorry, 2021.
Yeah, good. All right. So it will come over the course of this year.
Yeah.
Great. Is a point cloud with RGB near infrared in LAS 1.2 or 1.4 or both?
So with the near infrared, it is in 1.4, since the other last version does not support to include the additional channel.
Are you going to support other frame cameras? So I can double click on that. So it has not been decided yet. It's on our roadmap discussion for this year. So at the time being, I can't say no, but I also can't say yes. The internal decision has not been made. We will make that in the near future. Another question, there any, let's say, good practice to deliver an orthophoto based? Now, there are any, let's say, good practices to deliver an ortho based on the flight parameters? For example, a 20 centimeter GSD flight plan and also at 30 centimeter must have a specific planimetric accuracy?
Yeah, there are some formulas in literature which will tell you for a required output product what kind of flight planning and what kind of distribution of ground control points and so to do. So yeah, there are some, let's call it good practice guidelines to deliver the output product according to some requirements and what that means for the flight planning and so on. Yeah. So if there are specific questions in that regard, we are happy to help if you know details about your project.
Great. Is there a plan to include mobile mapping, point cloud imagery in the generation of the 3D mesh? Bernhard, in my understanding, there are no plans for the time being for that.
Yeah, short term, we are not planning to do that, but of course we are looking into that since there are some approaches on the market.
I hope there are 4 nadir cones in Osprey 4.1, 2 times PAN, 1 RGB, 1 near infrared. Can you explain more? If so, how about PAN stitching in water, tree, and desert region?
Yeah, so the number of nadir cones is absolutely right. So there are 2 panchromatic camera cones, and the images from these 2 panchromatic camera cones, they are stitched together in the post-processing. In this post-processing, there are type points extracted in the overlap region of these 2 parts of the sensor, and the stitching is not only done based on the type points in the overlap region, but also with having the RGB in the background. So the RGB serves as a low resolution reference plane where the panchromatic parts of the frame are registered and also controlled not to drift off in any direction.
Can we change projection in UltraMap? Example, our local projection, UTM or RSO?
Yes, so UltraMap is flexible with the projection that is being used. So the default projection, that is UltraMap, that is UTM, but you can use any coordinate system. So it works in that way that you can post-process the GPS data to any coordinate system that you need. It could also be a local coordinate system, so with very local coordinates, not any well-known system. And you also prepare the ground control points in the same system. You import the data, and then all of the image block is shifted to these new coordinates. Then UltraMap does the processing. So it is fully flexible, and as long as you then enter the correct EBS-G code, then also the information about this projection is applied to the GOT files and other files for exporting, so that georeferencing then of the exported files works well.
There's another, is it possible to get sample data of level 3 on Osprey 4.1? I would say that's possible. Please contact us directly. Is that the correct answer, Bernhard?
Yes, absolutely. Please contact us, and you will get details for the FTP where you can download sample data for the new Osprey.
I would like to thank you very much, Bernhard, for participation and presentation, and Claudia and Katerina for the preparation. And especially I would like to thank you, the audience, in joining us again for this webinar. It was what a great pleasure and honor to talk to you again. I really do hope that you find it worthwhile to attend. And I'm looking forward to meet you all in person soon again, hopefully. Hopefully that's possible in the near future. Yeah, we don't see any more questions coming in, so I would love to close this webinar. Thanks for listening. Thanks for taking part, and take care. Stay healthy. Thank you. Bye bye.
Thank you. Bye bye.